And today our lesson is on 5.4, energy resources. So in here, you can think of some examples of different kinds of energy sources. I'm pretty sure the first one come to mind is the fossil fuel, the one that you will see and use almost every day. In here, that's our first topic, fossil fuel. Now, in here, the human society are heavily relying on the fossil fuels. Doesn't matter you're in Europe, you're in Asia, or in North America. Most countries are reliable for using fossil fuels. Only a minor amount of countries can be living without the fossil fuels, but the alternatives have its disadvantage as well. We will discuss that in the second part of the, not today's lesson, but next lesson. Now, in here, we know that once the fossil fuels are used, it will take a very long time, basically millions of years, before it can be replenished. So that's why we call it non-renewable. There's no way we can actually renew it in the short human history we have. So that's why we call it non-renewable energy sources. And in here, we got coal, crude oil, and natural gas. And actually, in Hong Kong, we are still heavily relying on coal. We are switching a little bit towards natural gas. But some of you might realize that natural gas is actually pretty expensive in comparison to coal. Coal is cheap, but it's also really dirty. For the crude oil, and actually is a good alternative, but also expensive. Only recently can the price come down a little bit, depending on the economic demand of it. And right now, actually, you can buy a crude oil for $, meaning that they're producing too much crude oil. Instead of just $0 you buy it from, if I remember correctly, a couple years ago, it's costing $100 US to buy 1 barrel of crude oil. And right now, it's actually negative, meaning that they want to get away the excess production of crude oil at this point because of the illness being passed around. Now in here, let's take a look at the animation on how some of the fossil fuels can be formed. Okay, so let me just make it bigger so you'll be able to see it.
Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are 3 major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
Okay, so here's an introduction of what fossil fuels is. And in here, they actually mention something that I want to spend a little bit more time on. Is in this picture, you will see the little things that are flowing around. They call it plankton. And I want to spend a little bit more time on this topic because it's not covered in the uniform science as much as it should be. So in here, I will talk about the little things over there. Now, in here, the word is called plankton. So it's made of two words actually. Actually, plankton actually in Greek word actually it means that something is flowing around. So it's in water. So you take a look at the pictures. You see all the pictures here with the different types of planktons is flowing around. There are two major types of planktons, and I'll get into that in a second. Now, so let me show you this video on the introduction of the planktons. What makes the oil, the crude oil?
How did I get here? Well, it's a stranger story than you might think. I came from a world of drifters, a place few humans have ever seen. The world of plankton. I came from a batch of 1 million eggs, and only a few of us survived. When I became a larva, I moved among other drifters. My fellow plankton came in all sizes, from tiny algae and bacteria to animals longer than a blue whale. I shared my nursery with other embryos and juveniles, from clams and crabs to sea urchins and anemones. We drifting animals are called zooplankton. The most common animals here are copepods and krill. You could search the world over, but you'd never find a place more diverse than my childhood home. A teaspoon of seawater can contain more than 1 million living creatures. It can be a pretty tough existence, though. Trillions are born here, but only a few make it to adulthood. He may be no larger than a pinhead, but this crab larva is an arrowworm's worst nightmare. Epic battles between carnivores like these are just one way to get food. But the real powers of this place come from phytoplankton. Single-celled life that transforms sunlight and carbon dioxide into edible gold. Phytoplankton are the base for the largest food web in the world. During the night, many animals like me would rise up from the depths to feed on this sun-powered feast. I was part of the largest daily migration of life on Earth. During the day, I'd return to the darkness where I'd join my bizarre companions. Cannibals, like this sea butterfly mollusk that eats its next of kin. And comb jellies that beat cilia like rainbowed eyelashes. Some of these snare their prey with sticky tentacles, while others just take a bite out of their cousins. And siphonophores that catch prey with toxic fishing lures. But my favorite would have to be the crustacean Phronema. Its monstrous looks inspired the movie Aliens. It can catch tiny bits in its bristles, but prefers larger prey like salps. With 2 sets of eyes, this female prowls the deeper water. Prey in hand, she performs one of the strangest behaviors in the entire animal kingdom. With body parts from her victims, she delicately assembles a barrel-like home, feeding her young until they can drift off and survive on their own. Best of all, they make the perfect snack for a small fish like me. Here among the plankton, the food web is so tangled and complex, even scientists don't know who eats whom. But I do. At least now you know a bit of my story. There's so much more to me than just a tasty meal.
Okay, so in here it talks about the zooplankton here. The fish eats this kind of planktons. So in here, pseudo means that animal. It's from Greek, zoo. So basically in here, you know that it's some kind of animal. And in here, that's what they are eating, the other kind of planktons. And of course, the fish eat any of the planktons here. The reason why I mentioned the planktons here is because the cool oil and natural gas actually are mainly from these guys. The microorganisms that you can barely see. And in here, the second type of plankton is this type.
Oceans in the Northern Hemisphere have become a little less crowded. A new study led by NASA researchers has found populations of the microscopic marine plants, phytoplankton, have decreased in recent years. Individual phytoplankton are invisible to the human eye, but they can be detected from space by looking at the color of the oceans. Using a NASA model in combination with ocean satellite data, scientists observed in the Northern Hemisphere a 1% decrease of phytoplankton per year between 1998 and 2012.
Phytoplankton are the first level of the food chain. They feed fishes, but also larger mammals, including whales. Plus, phytoplankton, just like trees, absorb carbon dioxide and emit oxygen. So there is a constant exchange between the ocean and the atmosphere of gas. In fact, the ocean absorbs about 25% of the carbon dioxide that is emitted by humans. We don't know whether that decrease will keep on going, but what we know is that this decrease could likely have an effect on carbon dioxide in the atmosphere and the food chain.
Okay, so in here, that's what the NASA is telling us. They observed that the pseudoplanktons and in here the phytoplanktons are actually decreasing. So actually it could be a cause of concern because, as I mentioned, it actually absorbs some of the carbon dioxide, as in this video indicates. And let's go back to our PowerPoint and carry on with the topic of the energy here. So in here, next time you look at the coal or the crude oil, you realize that there's the tiny microorganism that lives in there was plankton, okay? So in here, I want you to have an idea. It's just not just animal or plants, there's a lot more to it. And it's actually pretty important for you and me and the global warming that's happening around you as well. Now, in here, let's take a look at what the textbook has given you. So in here, millions of years ago, before the dinosaurs, there's this kind of plants, and you see the fangs over there, and actually it's there already, and it's still here today. And after it dies, it got buried. So the trees and all those things, they absorb carbon dioxide. And what it does is, with the high temperature and high heat and high pressure, you have to be compressed, and it forms the coal. So in mainland China today, it's one of the major producers of coal around the world. And that's one reason why China is so polluted, is because people are still burning a lot of coal, because it's a cheap way of getting energy. In here, in Hong Kong, we still use that as well. And if you have a chance to visit the power plants in Hong Kong, you will realize you pick up a coal, it's really dirty. And people work there have to wash every day to clean up themselves, the coals. Now, the second type we want to talk about is the crude oil and the natural gas. So this time we talk about the dinosaurs and other things, and of course, planktons. I can't emphasize enough on the importance of planktons here. So in here, after it died, it got buried. The planktons, the microorganisms, you can barely see, die with that. So they settle down at the bottom of the ocean, and it got covered up by the sand. And guess what? After millions of years with the high heat and high pressure, and then basically it's like a pressure cooker, and just squeeze it, and then basically it turns into crude oil, the one that's really dark over there, and way above it is natural gas. So both of them go hand in hand. If you get a crude oil, the top will have some natural gas left with, and those natural gas, chances are people will just burn it off, and it's because crude oil is actually more important for the operations to extract. So in here, crude oil is seldom used directly as fuel, but we can refine it. For natural gas, that's what we can use directly as a fuel. We just burn it. Now, in here, let's take a look at the key point here. Fossil fuels take a very long time to replenish after they're used. That's why they are called non-renewable resources. We cannot replenish it in a million years. We cannot do that. Within a human lifetime, we cannot replenish that. That's why it's limited. It's called non-renewable. Now, in here, let's take a look at some of the activity we can do with that, in concern with the fossil fuel. And we know that there's a limited supply of fossil fuels, and in here, let's take a look at next PowerPoint, how we use the energy today compared to the past time. In the past, people used candles, and actually in the Western society, they don't only use candles. It's around 100 years ago, they used the wells, the oil from the well, because it's really frequent and it's really cheap to get them as burning oil as well. So people don't really actually use that much candle in our 100 years ago. They use the well's oil, and actually it can produce quite a bright light without all the smoke and other things you don't want with it. And transportation, you can see that in Hong Kong particularly, we use a lot of human powers to move people around. And of course, before the industrial revolutions, that's highly labor intensive, with a lot of human beings producing only a small amount of resources and other things, the products. Compared to today, we just need a few workers and a lot of machines. Of course, the machines would consume energy. Where does the energy comes from? The power plant, and most likely is from the fossil fuel. So in here, can you tell why we are using more fossil fuels than before? It's kind of obvious. Today we need fossil fuels to generate electricity and to power different machines and appliances, and therefore fossil fuels are also used for transportation needs as well. We want to move around, we want to travel from one place to another. We can use the oil, gasolines, or the airplanes one. The fuel as well is also considered to be fossil fuels. Okay, so in here a lot of manual labors in manufacturing compared to what we have today. And in here, of course, we know the fossil fuel will be used up. And how long can it last? It's a good question. People are making some guesses on how fast the resources can be consumed within your lifetime. Let's take a look at this exercise. So in here, we got some numbers, the data file 1 and data file 2. Let's take a look. Now in here is from the BP, the British Petroleum Company. They got the data from. So you see how many barrels or how many tons of resources are we using as of today, and compare that to natural gas. It's not as much in terms of the sheer volume, but it's still quite a lot. Now in here, there's just a quick summary of how many tons and how many millions of cubic meters of natural gas, all the natural resources we're using in here. So in here, if we just quickly take a look at how fast the world is consuming the coal, oil, and natural gas. So the first one we got is around 3,800 million tons. Okay, the next one, it comes to around 4,300, and the last one is 3,500. Okay, so all these numbers, and let's keep in mind we're going to do that a quick calculation in a second in question 2. So in here, we want to estimate how many years can we use this kind of fuels. So for coal, it's around 200 years, not too bad. Maybe your grandkids will run out of coal. But for the crude oil, it only lasts around 56 years if we keep today's consumption rate. And how old are you now? I don't know, plus that number to 56. I would assume a lot of you are still alive at that point. And for natural gas as well, you can see that it's around 53 years. So plus the age you have, that will probably be within your lifetime. You will see that the crude oil and natural gas will be running out. Now, what assumption have we made here? So in here, we are assuming the consumption of all these natural resources, the fossil fuels, remain unchanged. If we keep it up as burning all these things at today's rate, that would happen. And of course, the reason why you're watching this video is because you're stuck at home because of the sickness is passing around. And for that, this consumption rate decreased quite a lot. So I guess it's good news for fossil fuels. It lasts for a couple more years. And for B, so they will eventually use up. That is not an if, that is just a when. It's a matter of time. All the natural resources will be used up. Okay? And actually, there is one more thing I want to talk about before I want to go to carry on with the pollutions and global warming. Actually, it's one of the topics that even China is spending a bit more time on this. I want to show you that in here. It's called methane hydrate. So some of you might have seen this before. This is from the bottom of the ocean, and people can pick it up. It looks like a piece of ice from the bottom of the ocean. So take a look at this. And in China, in the China Sea, there's a lot of it at the ocean. And that's one of the new non-renewable resources we are discovering as of today. Well, this decade. So let's take a look from the beginning. So we're diving in the ocean.
I'm participating in Neptune at the gas hydrate sites. Gas hydrates are methane in form of ice. They look like snow, basically. They form, in that case, close to the sediment surface under specific temperature and pressure conditions. It's a huge compact energy source, which is of great interest to both climate investigators and also the energy companies. People think that they might contain more energy, more fossil fuel energy than all the other fossil fuel sources on land. For us, it's very important to see whether there's an effect of climate change, slowly increasing bottom water temperatures on the release of methane. It's very important to understand the behavior of gas hydrates under different temperature conditions, because if you slowly increase bottom water temperature of Canada, that kind of sudden release of methane from these gas hydrates could occur. That's one thing. It's interesting to find out whether small seismic events or larger seismic events, small earthquakes, have an effect on methane release. Or maybe it's possible that we can detect an upcoming earthquake because before it happens, slowly or just short before it happens, more methane is suddenly released and we don't know why. It happened before, about 8,000 years ago, after the last glacial time, one instability occurred in northern European waters around Norway. You can imagine that when there's, like you have snow in the sediments and suddenly all the snow is gone. That would mean the sediment sits on nothing. And that, as a result of that, the sediment can suddenly slide down the continental margin and like creating an avalanche. And that affects, if it's on large scale, this avalanche can then create a tsunami wave. And that's what probably happened at that time. And that tsunami caused a wave which was more than 30 meters high at the Norwegian coastline. And most probably the gas hydrates were the reason for that. Because of global change, the bottom water temperature slowly starts to rise. So we must be careful. We don't know yet what can happen, but we definitely know that it can happen again.
Okay, and this one is the gas hydrate. They have different names. Basically, it's the same thing. And let's take a look at it. You can burn it. And China is really looking forward to mining these resources. I can tell you that today. And Japan as well.
Methane hydrates have fascinated the community for decades now. This stuff is cool. So methane hydrate is a combination of water molecules and methane, where the methane sits inside a cage of these water molecules and it forms at high pressure and low temperature. The methane hydrates that we commonly talk about are in the Arctic and the other very common places on continental margins. So as you go into the offshore the combination of cold water and high pressure leads to a province of methane hydrates. Methane hydrates are a huge potential energy resource. There's an estimate that there is 7,000 trillion cubic feet of methane available in these hydrate reservoirs in the Gulf of Mexico alone. To give you a sense of what that means, that's 250 years worth of gas given our present consumption rates in the United States. So it's a tremendous potential supply. The problem is how to produce methane hydrates economically and environmentally. We don't understand how the material behavior of these rocks changes as we produce them. If you take that methane hydrate from depth and you don't control the pressure and the temperature, it's going to disassociate. The majority of it has just bubbled off into the atmosphere as you've raised that rock. One of the most fascinating challenges of this project is to be able to drill and sample these hydrate deposits. We're drilling a hole in a mile of water, and then we're drilling a hole almost 1,000 meters below that. You've got to go down to that area. You've got to take what we call a core, a small cylindrical sample of the rock that has methane hydrate into it. And while you're down there, you need to seal that sample inside of a pressure vessel, like a pressure cooker, because that sample is under pressure and you have to safely store that sample for further analysis. Look, in the United States, natural gas is revolutionizing our energy supply. We're using more gas instead of coal. We're lowering CO2 emissions. And here's a resource where we know there's tremendous amounts of methane, of natural gas stored. And we want to explore the potential for that as a fuel of the future. The University of Texas is taking the lead of actually sampling these potential hydrate reservoirs in the Gulf of Mexico. At the Jackson School and at UT as a whole, we're committed to making fundamental advances. And we're also excited when there's the potential for those advances to have societal impact. A better understanding of the methane hydrate resource has the potential to change a lot of lives down the road.
Okay. So maybe some of you want to go to US and study in that University of Texas. Well, at least that's what they're doing the research on as of this point. But mind you that all this one, as you can tell, is burning, and it's methane hydrate. Actually, it gives out a lot of carbon dioxide, even after you burn it. You can think of it a little bit more like fossil fuel, like natural gas. So once you burn it, it still produces a lot of pollution. That's our next topic we'll go into. So in here, some of the problems we encounter. So when you burn it, what will happen? You see all these different things. Some of it, you have some idea what those are: carbon dioxide and carbon monoxide. You don't really smell it because it's you don't have any smell to that. But when you inhale a lot of that, it could kill you because you don't have enough oxygen in it. Lead is heavy metal. Nitrogen oxide, NO, and sulfate dioxide, SO2. So in here, you see all these different kinds of things here. That is actually around you. You just go downstairs to where the bus depot or any streets, that as long as you see cars around you, this stuff will be around you. It's sheer number of the quantity. Is that a lot? Or is it not enough of it? Now, so in here, how do we associate with this kind of problems here? Of course, the first one is air pollution. It causes you to be diseased, you feel weak, have a headache, your eyes, your face is a little bit burning, and your trachea, your lung is not helping you breathe enough oxygen in. For global warming, of course, you know what that is, because it will trap more and more heat in it. Okay? It can't bounce off Earth. That's the problem. So in here, it makes a bigger layer and traps more heat. So you will feel hotter and hotter in Hong Kong. And as for global warming, it really speeds up a lot of things in terms of the ice melting, the water levels rising, okay? And last but not least is the acid rain. In here, all this compound would turn the normal rainwater into acid rain. So it's acidic. It will actually basically want to react with something. So it's called acid rain, that's the reason for that. Now in here, the reserve of fossil fuels are limited. It's a scatter. They don't have abundance of it. It's limited. One day we will run out of these resources of fossil fuel. And in here, the health and environmental disadvantage are obvious. People can observe that now, and scientists can prove that already. So in here, let's do some of the checkpoints here. For example, the first one, fossil fuels were found from the remains of dead plants and animals millions of years ago. True or false? So you should be able to tell me that it's true. And for some reason, okay, I need to come out of this to show you the other two. In here, B, crude oil will never run out. Of course, it's false. And that's why we do the quick calculation there to show you that within 50 years, it will run out. And next one, the burning of fossil fuels will release large amount of carbon dioxide into air. Well, you know it's true, okay? So in here, and we talk about some other ideas here. Those things will not be in the exam for sure, but I think it's important for you to know what those are. And then in our next lesson, we will talk about the alternative energy resources. So that's the end of today's lesson.